Good evening. We are going to see one problem again, that is on shear. So we have this reinforced concrete beam 230 mm wide and 375 mm effective depth is subjected to factorial UDL as shown in figure. And percentage of steel is given 0.75%. Design shear reinforcement M20 and Fe415. Width of support is given 250 millimeter. Now you can see we have this UDL is given, span we have 6 meter. So we can say 50 into 6, 300 kilonewton. So reaction we have that is 150 kilonewton. Keep in mind this reaction we have at center of the support. This reaction is at center of support. So now we will switch over to the shear force diagram. So we have 150 0 at center and 150 we have that is at other end. So now VU we have 150 kilonewton. Now we are interested to calculate value of VUD. Now how we will get value of VUD? So VUD we know which will be at distance D from the face of the support. So from face of the support means from center we have Bs by 2, that is width of support by 2 plus D. And then we have that will be Bs by 2 plus D. And that is our critical section. Now then we have Vu minus Wu because we have to subtract UDL of this portion. And this we have B by 2 plus D. So Wu B by 2 plus D. Now 150 minus 50 we have UDL given. So width of support is given 250. So 0.25 by 2 plus effective depth is given 0.375 and that we will get it as 125 kilonewton which is VUD. So VUD we have 125 kilonewton. Now we have table 19 and in this we have given tau UC value. Now we have percentage of steel as 0.75% from which we will get value of tau UC that is 0.56 Newton per mm square. Now VUC from this we will get as tau UC B into D. So tau UC we have 0.56, B 230 and D we have 375 which will gives us value that is 48.3 kilonewtons. So knowing this value of VUC, we will find value of VUSV minimum and we know this value of VUSV minimum is 0.4 B into D and that will gives us value 34.5 kilonewton. So we have VUSV minimum, we have VUC and which will gives us VUSV or VURSV minimum equal to VUC plus VUSV minimum. So this is VURSV minimum means combination of VUC and VUSV minimum gives us 82.8 kilonewton. Now we will go with we have this value VUD 125, VU 150 kilonewton, VURSV minimum 82.8 kilonewton. Now we will find the distance where we will get this value 82.8 because we have 3 meter. This is 150. By using similar triangle, we will get value x upon 82.8. So we have considered this distance as x. And then we have x upon 82.8 equal to 3 upon 150. So 3 we have this value. And from this we will get x equal to 1.66 meter in which we have to provide minimum shear reinforcement. So this is the reason where we have to go for minimum shear reinforcement. And in this region, we have to go for design shear reinforcement. So as we have 3 meter, this value 1.66 meter. So automatically this comes 1.34 meter. So now minimum shear reinforcement we can find by using formula SV equal to 0.87 Fy ASV upon 0.4 B. Now this will be assuming two-legged 8 mm stirrups which will give us value of SV as 394.48 millimeters. Now we have this 8 mm diameter and for this 0.75D we have 281.25 millimeter and we have third criteria 300. So we have to go minimum of the 3, and minimum of the 3 we have 280.25, and we will have spacing is minimum of 3, and then we have to provide 8 mm tor at 280 mm center to center, and provide 8 mm tor at 280 mm center to center. Now go for a design shear reinforcement. Now we know, assuming two-legged 8 mm stirrups, and we have formula SV equal to 0.87 FI ASVD upon VUD minus tau CBD. This VUD minus tau CBD is nothing but we have VUS. And this we are going to consider VUD 125. Tau CBD we have calculated 48.3, and this is in kilonewtons, so we have made it in newtons. Then we have 0.87 FY, we have 415 ASV, 2 into 50.26 because we have two-legged, and D we have 375. Then from this we will get value of SV as 177.44 millimeter. Then again we have to go three criteria. So 0.75 D we have 281.25 millimeters and 300 mm. And then out of these three we have to consider minimum, and then we have spacing is minimum of 177.44, 281.25 and 300, and we have 8 mm at 170 mm center to center as design shear reinforcement. So now we can show this design shear reinforcement. So we have to provide this value, that is 8 mm tor at 280 mm center to center in a region of 1.66 meter from center of the support. And then we have to provide design shear reinforcement in this 1.34, and that is at 170 mm center to center. So though we are going to calculate VUD, but we have to provide a reinforcement till end of the support, and that is design shear reinforcement. So we have these regions, and in these regions we have to provide minimum shear reinforcement and design shear reinforcement. So these are the problems which are related with your shear, and we will stop here only. So thank you.